Good afternoon. My name is Maria Martínez. My partner is Reyes, and we will talk about the operational amplifiers. An operational amplifier is an electronic device used to amplify electrical signals. It is one of the fundamental building blocks in the design of analog electronic circuits. The typical operating amplifier has two inputs, one inversion input and one non-investment input, and one output. The output is the difference of inputs multiplied by a Willen factor. Opamps have a wide range of applications, including signals amplification, signals filters, adders, restarers, integrators, and shunts. In the figure, there are two bipolar feeding pins, a non-inversion input and inversion input, and an output input. We also see positive power supply and negative power supply. Types of operational amplifier. Inverter, not inverter. An inverted operational amplifier will increase the gain of the signal and also reverse the polarity of the output signal from positive to negative or vice versa. Addition subtraction amplifiers. A subtraction amplifiers pulls out a signal that is equal to subtraction between its two inputs. A summation amplifier combines different voltages from a number of inputs and draws a gain based on the combined voltages. Any of the circuits can be configured to operate as inverted or non-inverted systems. Integrators and differentiators. The sum of the capacitor to the circuit means that the integrators react to changes in voltage over time, and the magnitude of the output voltage changes based on the amount of time a voltage spends appearing on the input. The differentiators is the opposite, and of this, the voltage produced in the output channel is proportional to the rate of change of the input, and large and faster changes in the input voltage will produce higher output voltage. And finally, voltage trigger. A voltage trigger is used to increase the signal of circuits with variable voltage. It applies the same type of gain as the startant amplifier, but variation in the input gain will be triggered and matched by the output signal. Such circuits are often used ahead of other systems to prevent damage from sudden voltage changes. Now, pin configuration and functions. Pin 1. Pin 1 offset node. This pin used to remove offset voltage and balance input voltage. Pin 2 inverted input, inverted signal input. Pin 3 no inverted input. This use no inverted signal input. Pin 4 is negative supply voltage. Pin 5 offset node, node offset pin used to remove offset voltage and balance input voltage. Pin 6 output, amplify signal output. Pin 7 positive supply voltage. And finally pin 8 no connect, must be left floating. Offset. When we work with an opamp, in most cases we are looking for a mathematical operation with input voltage. Ideally, if the amplifier does not have an input voltage, the output voltage should be 0 volts. However, if you do a physical exercise, you will notice that the output voltage is not 0. Even if you do not have anything connected in your input pins, this error is called the imbalance voltage or offset. We could define is the non-zero voltage that is measured at the output of an operation amplifier, even if its input voltage are 0 volts. Depending on the different types of operational amplifiers we use can vary the offset voltage. Unfortunately, most amplifiers have pins to eliminate the noise generated. In the case of the LM741, one of the most used, the pins to eliminate this error are 1 and 5 pins. To determine the offset voltage, potentiometer is connected between the pin 5 and pin 1 of the operational amplifier so that the error can be fixed. And finally, input offset voltage has a maximum of 5 millivolts, a typical 1 millivolts, and there is value determined for the minimum. In the input offset voltage adjustment range has typical more and less 15 millivolts, and for the input compensation current a maximum of 200, a typical of 20. And finally, maximum of the 500, a typical, and 85. Power consumption and power current. The power consumption of an operational amplifier is usually expressed in terms of power dissipated in the device. This can range from a few milliwatts to several watts depending on the application and amplifier design. And it is important to denote that power consumption can increase significantly in the amplifier is operation under overload condition or if high power voltage are used. The power current. The power current is the current that the operational amplifier extracts from the power supply. It can range from microamperes to several milliamperes, again depending on the amplifier design and load. And low power operational amplifiers are designed to minimize this power current, making them ideal for low power applications such as battery powered devices or portable systems. Now, in the input bias current, there is a maximum of 500 nanoamps and also a typical 20 and also a maximum of 1.5 microamps by input bias current. The CMRR common mode rejection ratio is a measure of the ability of an operational amplifier to reject signals that are common to both inputs, signals that appear on both inputs at the same time. The CMRR is a typical expressed in decibels, dB, and is calculated as the ratio of differential gain when the signal is applied differential to inputs, to common mode gain when the signals to common mode gain when the signal is applied in common to both inputs. The formula for CMRR in decibel is this. The CMRR is an important measure of the ability of any operational amplifier to reject noise and unwanted signals that appear at the both inputs at the same time, such as electrical noise induced by external electromagnetic fields. A high CMRR indicates that the operational amplifier is effective in eliminating these unwanted signals. Where ADF is the differential gain of the operational amplifier, ACM is the common mode gain of the operational amplifier. Now, the common mode radiation ratio has a typical 95 decibels and a minimum 80 decibels on the other And the supply voltage radiation ratio has a typical 96 decibels and a minimum 86 decibels, and both do not have a maximum value. The PSRR power supply relations ratio is a measure of the ability of an operational amplifier to reject variations in the power supply. In other words, it indicates how much the amplifier rejects fluctuations in power supply, such as current or change in power voltage. The PSRR is typically expressed in decibels dB and is calculated as the ratio between the supply voltage variation and the corresponding variation in the operation amplified output. The formula for the PSRR in decibels is this. The PSRR is an important specification, especially in applications where signal stability is critical and the power supply can be noise or subject to significant variations. A high PSRR indicates that the operation amplifier is affecting the mains output stability even when the power supply varies. Now, gain. Large signal voltage gain. From an operational amplifier is a measure of how much a large input signal or significant amplitude amplifies. The voltage gain in large signal is usually calculated when the input signal is large enough to cause the operational amplifier to not work in its linear range. In many cases, operational amplifiers are used in a linear range where the output is proportional to the input and the voltage gain in that region is calculated. However, in applications where the input signal is large and the operational amplifier can reach saturation, the voltage gain in large signal can be calculated as the ratio between the changes in the amplitude of the input signal and the corresponding changes in the amplitude of the output signal. Now, large signal voltage gain has typical 200 millivolts and 15 minimum millivolts, and finally, minimum 25 millivolts.
Input voltage range. The input of the operational amplifier must remain within a certain voltage range for proper operation. Each of the other input pins of the operational amplifier has voltage swing restriction, beyond which the operational amplifier will not function properly or will behave non-linearly. Non-linearly means that in addition to a change in signal amplitude, the information contained in the signal changes and new information is introduced. In some cases, if the input signal exceeds the specific range, the amplifier may distort the output signal or even be damaged. On the other hand, if the input signal is low in relation to the amplifier range, the output signal may be weak or inaudible. For this amplifier, under normal condition, the minimum input range should be 12 volts and the typical input range is 30 volts. Output voltage swing. The output voltage swing defines how close the output of the operation amplifier can be driven from one rail to another, either an electrical rail, VDD, or VLS, under defined operating condition where the operation amplifier can still function properly. In other words, the output voltage swing of an amplifier is the maximum difference between the highest and lowest value of voltage it can generate at its outputs. It is maximum amplitude of the output signal that the amplifier can produce, measured in volts. In this case, according to the datasheet, the test was performed with an input voltage of about 15 and an output load of a low impedance of 10K with a minimum voltage for 12 and the typical of 14, while another impedance for 2K. The minimum voltage is 10 and the typical is 30. The output voltage swing is an important parameter to consider when selecting an amplifier, as it determines how large a signal and it can effectively drive. An amplifier with a higher output voltage swing will be able to amplify higher amplitude signals without distorting them. The output voltage swing is also related to the maximum power the amplifier can deliver, since the higher the output signal amplitude, the more power it can handle. Supply voltage, VDD GND. Supply voltage is the electrical potential difference between a voltage reference point, commonly referred to as ground or GND, and the electrical power supply point, commonly referred to as VDD. The VDD GND potential difference is essential to determine the maximum voltage that can be applied to the amplifier without exceeding its voltage limit and therefore without risking damage to the device. The relationship between the supply voltage VDD and the ground voltage GND determines the effective supply voltage of the circuit and is critical to ensure proper operation. In this case, for the LM741 amplifier has a normal value of 15 volts, a minimum of 10 volts, and a maximum of 22 volts. Output short circuit current. The output short circuit current or output short circuit current in an amplifier refers to maximum current that can be supplied by the amplifier output stage when a short circuit occurs the load connected to the amplifier output. Under normal operating conditions, the amplifier supplies a given current to the load connected to its output. However, if a short circuit occurs in the load, for example, if the leads touch or if two terminals of the load are accidentally connected, the resistance of the load is reduced to 0 ohms, resulting in a short circuit and an extremely high current flowing through the output stage of the amplifier. The output short circuit current is an important specification that indicates the amplifier's ability to handle short circuit loads without damage. An amplifier with a high output short circuit current will be able to supply a higher current in the event of a short circuit, which can help prevent damage to the amplifier. In this case, at an ambient temperature of the 50 degrees, the typical current will be 25 millivolts. To check the current value, a simulation for a non-inverting amplifier with a gain of 1 volt was made that two resistors with very low values were placed so that the current will reach its maximum level. The operating temperature of an amplifier is the ambient temperature within which the amplifier can operate safely and efficiently. This temperature refers to the temperature range in which the device can operate without degradation in performance. This range is specified in the datasheet and in this case range from -50 to 125 degrees Celsius. And this is all. Thank you for your attention and see you later.